Hola, buenas tardes. Mi disculpa, pero no puedo hablar español. Puedo hablar lente in English. So I will try to speak slowly in English. My name is Ofer, and I'm from California. I'm with Smart Network. And a little bit about myself before we start. So I'm a certified MikroTik trainer on these certificates. I mostly focus on the wire technology. I also have some certificates from the other company. I started my path as a UX designer in the military many, many years ago. That's user interface. So I developed interfaces for databases and telecommunication systems. But for the past 15 years, I spent my days, my noches, my weekends building rural networks in Northern California. The company name is Valley Internet, and that is actually the company that started Smart Network. I also have 2 teenagers at home. They're doing selfie there on the graphics. And that's kind of important for today's presentation. It's interesting how you match teenagers with Tls Hosts Matching, but we'll get to that in a minute. Generalmente, usually, I start with the problem, and then I go to the solution. Today I'm going to do it slightly different. I'm going to show you something that we built the solution, and I'm going to use that to bring us to the Tls Hosts Matching discussion and how we solved some issues in that solution. So Smart Network was built to address chronic tech support calls. Chronic tech support calls, I call difficult tech support calls. One of them that is most famous is, my network is slow. How did my friend here says? Mi rede es lente. I think it's in every language it exists. My network is slow. Why is it slow? But not just that type of call, also what's taking up all the bandwidth? Why, or who is using, the network? We have a lot of customers, and I see people nodding their head. People call and say, "Is my neighbor using my Wi-Fi?" And recently, also questions like, "Can I see what my teenagers are doing online?" And the reason why these calls are so important for our industry is because they take a lot of time. They're not like, my internet is off. Okay, have you tried turning it off and on again? That's easy. That's 5 minutes, unplug the power, and it's back online. These calls require attention. These calls require that both the customer and the agent be able to talk at the same language, be able to see the same thing. And in fact, that's not what's happening. Usually what's happening is the customer will see buffering on their TV, and the tech support will see some IP hogging all the bandwidth. The tech support talks with IP, the customer talks with, I don't know, it just doesn't work. And that's a challenge, and that's why those calls take so long, is because they don't see each other, they don't see the same thing as far as the network is concerned. One is saying, "No one is using my network." And then the other one is saying, "Well, your network is maxed." And usually we get asked, what does maxed mean? What do you mean my network is maxed? So we thought, what if we could change this? What if we could make the customer and the agent see exactly the same thing? Are you familiar with Log Me In or PC Anywhere? How many of you are familiar with PC Anywhere? Raise your hand. Okay. That's really easy to troubleshoot, right? Because If you want to help somebody on the PC, you just log into their PC and you see exactly the same thing. Okay, here's how you select config, system preferences, etc. What if we could do the same thing for networks? What if the customer and the agent could see the same thing in simple terms, device names, users, services, and then they can work together to troubleshoot the network. Or maybe they don't even need to because the customer would be able to troubleshoot it themselves. And that's what we did. We built a system that connects every single MikroTik is capable to connect to the smart network. So we're connecting the MikroTiks, the end user app, and the agent, and they all see the same thing. So I'll quickly give you a demo of how it works right now, and then we'll dive from there into TLS Hosts Matching. I'm going to share my iPhone so you guys could see it in real time. I need to be on the same Wi-Fi network. So here's my iPhone. It's always interesting when the whole world can see exactly what's on your home screen. Okay, so let's say that we are the customer, okay? And the network is slow. So with Smart Network, you can launch the app. It says your logo is here because I'm running on a development server. And I could see exactly what's happening on the customer network. That's the customer itself holding the app and looking at their own network. Right now, you're looking at my home network back in California. And what the app can give you in the home screen, a lot of information is if you have data cap, you could see where you are relative to the data cap during the month. So like, for example, I've got 999 gigabytes and I'm more than halfway there. You could see in real time if the download is busy or the upload is busy. You can also click and see who is taking up the network in the last 90 minutes. Because a lot of the calls that come to support, my network was really slow, but it's okay now. Okay. Okay, so let's see what was going on. So it looks like Carmel, that's my oldest, is watching Netflix. And you could see that she was taking most of the network. You could see if the speed that the ISP said they'll give you is what the network is testing every 12 hours to make sure that it's there. And if I want to see more, I can just click and start to see. That's my wife. That's the Apple TV. That's the other teenager at home. It's really busy. It's Friday afternoon, so happy hour without dad at home. It's really happy hour. So right now I can actually go, and if the network is really busy, I can go to the Apple TV, and I can click on Netflix here, and they don't need to watch at 4K. That's way too much. So I'll just set them to standard definition, HD. And I could shave them down. Oops. And I can also set alerts and all sorts of things like this, so I could see what's going on if somebody is active at night or they're doing social media, etc. But what if the customer doesn't want to troubleshoot by themselves? What if they want to still call tech support and they want to talk to the agent about it? So we're going to log into the dashboard, the smart board. That's where the tech support is using, okay? And I'm going to, again, this is a development server, so there's not many customers here. So I'm just going to go to see my network. So I've got two networks here. One is the one running here, and one running at home. And I can actually ask to look at the network. So if I'm not asking to look at the network, if I'm just clicking here and I'm viewing the network, all I could see as an agent is I could see the last 90 minutes, the utilization calibration, and if the network is happy or not. And you could see that I'm seeing the same thing. The network is not too happy. But if the customer wants me to troubleshoot together with them, I can ask for permission to see the network. So I'm going to click on Ask for Permission. And it's going to pop up a screen on the user app. And I'm going to say yes. And so now I can do Log Me In or PC Anywhere or Team Viewer, whatever you want to call it, for the network. So I can actually click and see the home network and see exactly who's doing what. So if Linda is doing something on her, so my wife is watching YouTube, and it's the same as what my wife would see if she looked at the app herself. So you can see that she's watching YouTube and she's on Instagram. So this is really like changing the conversation. So now tech support and the customer, remember, they could see exactly the same thing now. And all of this was built on top of RouterOS using the Router API. Now let's go back to the presentation. So you remember that in the demo, I was able to see as an agent, I was able to see exactly what the customer could see. She was on YouTube, I saw that she was on YouTube. She was on Instagram, I saw that she was on Instagram. If we didn't have TLS host matching, it would look like this. That's the Dropbox ASN and some IP address, which is really not useful. So I think you're starting to get why TLS host matching is so important for delivering customer experience that is on a different scale, on a different level that we're used to. Now let's take a quick look at in history and see how did we get here. So in 2008, life was simple. First of all, we didn't have fake news. There was no fake news in 2008. And the data, the traffic on the internet was not encrypted. If you looked at data in 2008, you could see YouTube was on port 80, Netflix was on port 80, iTunes was on port 80. You could actually identify and look at every packet and see who's doing what they're doing without any issues. Fast forward 5 years, about 2013, if you look at the reports, about 35% of the internet became encrypted. And if you go to now, 90% of the traffic is encrypted. Pretty much right now, if you torch, you can't see anything. It's all HTTPS. Everything that we do, all the content that we consume is secure. I did see a few leftovers on iTunes and Facebook. There were a few port 80, but for the most part, packet inspection, the way we knew it, is gone. And that's where TLS host matching is. I think you're starting to get where that helped. So how do we classify traffic? We can classify traffic by ASN, who owns the IP. Unfortunately, when it comes to Amazon, that's not going to help you, because thousands of companies, millions of companies are on Amazon, and they're being serviced by Amazon IP. So if you're just looking at the ASN, you're going to get AWS. You can look at ports. If it's 25, if it's 993, you know, it's IMAP. So you could kind of narrow it down, right? Because, you know, take ASN and ports together, but many, many companies also overlap on ports. You could look at traffic patterns. And those are algorithms that are very difficult to obtain, but some of them are out there. And you can actually see if the packets are a certain size and they are symmetric, that's probably Skype. If it's not, it could be FaceTime. So there's lots of different things in traffic pattern that can clue you in. And of course, you could do DNS. But as of December 2017, since version 6.41, I believe that's the version that MikroTik added, TLS Hosts Matching, we get a lot more power to classify traffic. So TLS Hosts Matching, this is, you know, their definition from the MikroTik wiki. The most important thing about this definition is that it accepts wildcards. So you could look for things like YouTube.com, but you can also look for YouTube asterisks. Now, you'll find TLS host matching in IP, firewall, and then when you create a new rule, it could be a filter, a NAT, or a Mango rule, and you go to the Advanced tab, that's where you'll find TLS host matching. And that's where you get to type the host that you're trying to match. Okay, so if you're trying to look for traffic for Instagram, you would type Instagram.com here, and then you would get, you would be able to classify, you would be able to take addresses from servers that are answering with that. But there's a catch, and here's the catch. If you just classify by the domain name of the service you are trying to identify, you will hit and miss up to 50% of the traffic. And why is that? That's because YouTube, for example, is actually not getting the videos from a host named youtube.com. It's actually getting it from ytimage.com and googlevideo.com. So you need to know the TLS hosts that go together with the service that you're trying to match. Here's another example. CNN, BBC, Vimeo, Twitter. If you just match by Twitter, you're only going to get a little bit of access to Twitter. You also need to add the t.co. You also need to add the twimage.com in order to get the images. Otherwise, you're going to see some Amazon, Akamai, something else, but you're not going to be able to classify with the proper traffic. You could see that a lot of, like if you look at Hulu, this is Vimeo, but if you look at Hulu, it's exactly like Vimeo. It will say hulu.akamized.net. So you have to look for the related TLS host matches. And how do you do that? You go deep. I think that's their slogan with Wireshark. You have to go deep and you have to look at the packets. I'll show you a little bit how we do that. So for example, this is the router right here. It's a vanilla router. I didn't change any configuration. I just made it smart. Everything else is the same. And what I did here is I captured some packets. I wanted to look at Instagram. I wanted to see how do I capture Instagram. So in fact, I'll bring my phone back online and I'll connect to this network. Sorry. Trying to bring the phone so you could see it too. Do you see the phone? No. Okay. I'll quit. Trying to bring the phone so you could see what I'm seeing. It doesn't want to. Okay, here's Wireshark. Here's the router right here. And here is the packets that I captured. I'll look at them in a minute. So to capture TLS host, what you want to do is we're going to go to Tools, Packet Sniffer, and look at what I'm looking at. So for example, you can take a test, laptop, iPhone, and you want to go to Instagram. So I'm looking at the interface of the LAN interface. This would be the device that you're trying to capture. I'm capturing port 443 in this case. And make sure you change the filter to AND so that it matches both of these. Then you save the file. And this is the file that I just captured last night. And then you can open it in Wireshark. Now, notice that the Wireshark is already filtering it. This is how it looks like when it's not filtered. Okay, so you get all this data. But if you want to look just at the TLS host, you're going to apply a filter. That would be Handshake. And extensions. I don't remember all the... There we go. So if you apply this filter, look what happens. It will already look at just the client packets, the client hello packets. Okay? And you can go here. I'll close this so that you see where I find it. This is in the SSL. And I look at the handshake. I go to the server name. And in the server name, I could see the server that the app was trying to go to. And notice that one request was going to Instagram.com. Another request went to Instagram.something.something.Facebook, the Facebook CDN. And actually, what I found yesterday is that most of the traffic on Instagram in Puerto Rico, in Costa Rica, is coming from this matching. And of course, there's another one, and this one is just graph.instagram. And I'll show you how it matches it. Looking for my phone. Oh, it doesn't want to connect. Okay, I'll show you on the phone here. Okay, so I'm going to launch the iPhone, and I'm going to log into this network here. Right now it's going to my Tenenbaum network at home. I'm just going to switch it to the mom network. Can you see a little bit? And then I'm going to pretend that I'm a teenager, and I'm going to surf Instagram. Most of my Instagram feed is just my daughters. I'm apologizing what you're going to see. So as you can see, my computer here is busy, and you can see that it's finding that it's Instagram, right? So as I'm keep surfing, it sees that it's Instagram. Now take a look what happens when I'm going to turn off TLS matching. So this button allows me to turn off TLS matching. And you can see already that Instagram went away. And all I'm seeing here is the local Costa Rica IP. So if I'm trying to support a customer and all I see is some sort of a local CDN IP, I can't tell them, well, you're using Instagram, that's why your network is busy, or you're using Facebook, or you're using Netflix, or YouTube. So when we turn back TLS, so again, I'm like just surfing like this, and then I'll go and I'll turn back the TLS, and I'll keep on surfing, and you'll see that Instagram will pop up again. And now I can have a more intelligent conversation. That's it. TLS host matching for you. Make sure you use it when you classify traffic. Preguntas? Any questions? Thank you. Gracias.